Hey everyone, thanks for coming. Today we're going to talk about AI. Just get that out of the way. Wouldn't be a difference if we didn't say artificial intelligence or AI at least 3,000 times. But we're going to talk about it in the sense of how to build assistants and copilots and even a little bit of agent stuff for .NET developers. So are you .NET developers? Raise your hands, people who are .NET developers. Cool. People who didn't raise your hands, what, Python? No? Okay, good. All right, well, then we're in the right place. Because I don't do Python. Sorry. Just quick, a little bit about me. I've been doing this for a long time. I don't know if the lights are showing it enough, but I have a lot of gray hair, which means I've been doing Microsoft development for forever. Started off professionally in 1999 when it was actually just classic ASP, not even full .NET at that time. But today, I run an agency in Grand Rapids, Michigan. Yay, Michigan. Okay, last year I did that, and I had boos. So apparently people this year like Michigan more than last year. Well, we'll talk about it in a second. But for my expertise in doing this for a long time, I've been recognized as a Microsoft Azure MVP in a couple different, flavors. AI and platform as a service deployment of websites. I've been an MVP, I think, for 3 or 4 years. But my real day job is all about delivering enterprise-class websites that are based on top of content management services. So I've also recognized as a content AI MVP and a Kentico MVP. Those are headless and traditional CMSs. And I'm on social at McKeiver. That's my old high school nickname. Ask me later if you wanted to hear that whole story. But yeah, I've been doing this for a long time. And my company at BizStream, our tagline is we make digital flow. We work for people all across North America and do that e-commerce, custom apps, mobile, portals, all sorts of stuff on the web. We do everything in Microsoft Azure and have been doing that for a very long time. But enough about that. Let's talk about the topic. So AI is everywhere, and naming is hard. And I'm going to give you a little bit of some history, very recent history. But in 2024, this idea of copilots came out really from one man, and it's this man. Satya Nadella, the CEO of Microsoft, got in front of a very large crowd around Microsoft Ignite time last year and announced that Azure AI Studio is the future and copilots were going to be everywhere. In fact, he mentioned this exact quote, that we are a copilot company and they are going to be everywhere. We're going to deploy them in every product, every service, everything that Microsoft has. And everything you do will use copilots. And that's where the idea for this talk came from, because they're heavily investing in copilots and AI at Microsoft. In fact, he continued to go on to say that it's going to be your personal assistant. It's going to help you with any task. It's going to make you better, more efficient, stronger. They really were hyping it up. And that is still true, but some things have changed. So as we went into 2025, this idea of agentic AI has come out and has changed a little bit of the messaging from Microsoft. Has people heard the term agentic AI or AI agents? Yeah, many people know them, right? Because that's not what they talk about it. And in fact, Satya went on a pretty famous podcast, and the host asked him a question, is SaaS dead? Will AI agents take over? And his response to that is yes. I believe the AI agents are going to take over. SaaS is dead. And this is now the year of AI agents. He continued to say that AI agents were going to replace knowledge workers. Sound familiar to what we were saying in 2024? Yeah, it was like the same message, but different name. And then Meta picked up on it. And they're talking about AI agents. And then Salesforce. And then Oracle. And suddenly every tech vendor known to man has an Azure AI Studio of this, or a way to do AI for this. Even OpenAI came out and said that agents are systems that independently accomplish tasks on behalf of users. So they try to define it, and this is roughly the March-ish timeframe of this year. And frankly, I think it's all best summed up with this headline by TechCrunch. No one knows what the hell they're talking about, right? It's ridiculous how fast the pace of innovation is in AI and how fast this has all changed. and how fast we have these big tech players just using different names for things. Copilot this, assistant this, AI agent that, right? And that's when I really was starting to work on the beginning of this talk, and I had this moment of, yeah, what the hell is this? What are we doing here? And finally, I found something that I think truly defines what AI agents are that made the most sense to me. Agents are systems that can reason over a business process. They can retrieve context to complete the process, and they can perform actions for end users. It's not just chatting and getting information as an end user. The definition of an AI agent is when it can actually accomplish something and do something for you. So just one of these by itself wouldn't really fully define the agent, but I think all three together do. So I'm hoping that we can get all on the same page, at least in this conference, with what AI agents are things that they can reason, retrieve context, and do actions. That is what we're going to show how to build going forward. In fact, surprise, we're at a new talk. I've changed the name. The real name for this talk is How to Build Your Own Copilot and AI Agents for .NET Developers. And we're going to go through those options because, frankly, there's a crap ton. If I asked everyone in the audience, we might come up with a different tech stack or a different framework for how to do this. So my goal today is to showcase a little bit about Microsoft Copilot Studio. Anyone in the room use Microsoft Copilot Studio? Just a couple. Cool. That's what I expect. AutoGen. Anyone in the room use AutoGen? All right, one. Semantic Kernel? Couple. Good. Azure AI Foundry? Microsoft Extensions AI? I mean, I can keep going. Azure AI Surgeons, and there's probably yet another thing. So I'm going to actually cover these 6 things. And my goal for this talk is to have you leave this room knowing what these are at a pretty good level, not maybe fully experts, but a good level of understanding them and knowing when to use which one. Because it is not clear if you just do some Google searching, and it is not clear if you actually just ask an assistant or a chat GPT. Everybody with me so far? Does that make sense? Cool. So in fact, let's start diving into each one. Microsoft Copilot Studio. You know, we had a couple people in the room raise their hand. But this is, I would say, the longest running solution in this stack of stacks. And it's a low-code solution that's meant for both business users and technical users to create copilots and agents and deliver them in the Microsoft stack. So as long as you have like an M365 account and privileges to do so, you can actually, without any code, develop a custom copilot for your organization, distribute it to your teams, and have it do things. And the way it works is a lot like low-code solutions that have connectors. So there's a set library. There's actually a large amount of connectors that Microsoft Copilot Studio has to allow it to do things. Has anybody ever used Azure Logic Apps or Zapier as an integration platform? Yeah, more people. It really reminds me of Azure Logic Apps. It's something that's very similar to where it's a lot of configuration. You're clicking new button, new connection. You're tying in maybe your authentication or some API keys. And that's what allows you to use things like push a lead to Salesforce or look up the weather, you know, do some things with Dropbox. That's what this list is showing. And to add an assistant into a copilot that's yours, you actually start out with just text. In fact, I'm going to actually hopefully zoom in. Well, I don't know if that's going to work. Can you guys see that instructions field? This is the part of the agent that I added to make this assistant and agent work the way I wanted it to. So I clicked Agents, I clicked Create New, I gave it a title of Google Calendar Assistant. Because the reason I wanted this to work was this was right around the Super Bowl time in February, and I'm a huge Detroit Lions fan, and I thought that they were going to make the Super Bowl. They didn't quite make it, but I wanted to put a reminder on my calendar, and we use Google at BizStream to do so. And I thought, what would be cooler if I could just talk to my Teams client or talk to Microsoft Copilot and just have it add Google Calendar reminders for me. So that's where the idea was born. And when I first started to do it, I dragged in the Google Calendar connector, because there's one out of the box, and I just clicked go without putting in any instructions. And what did it do? It actually worked. But it created an event in the complete wrong time zone, and it created it not as a reminder type, and it wasn't quite what I was looking for. So by giving it instructions, telling it that, hey, when I want to make a new event, only make it 30 minutes by default. I want to make sure it's in the correct time zone. I was able to fill in those tasks, and because I'm using the orchestration enabled at the bottom, it's using an LLM to understand what those tasks are and control the behavior of how it's calling the API to Google Calendar. And whenever I would, test in the tester agent side, it would just work. So it actually got pretty far without writing any code, and that's interesting. But that's actually not why most of us are here, right? Most of us are .NET developers. We want to talk about code. So I would say this is a great use case if you want to build something quickly and you're not a developer. So a power user, an IT pro, someone who needs to do something in business, this makes a lot of sense to use this. And the benefit is it has an automatic deployment of whenever you create an agent or a Copilot, you can push it right to the channels that you work with in the Microsoft ecosystem. So the entire Microsoft Copilot Studio allows you to build Copilots, deploy them, have agents, and ultimately get it to end up in Teams. So this is my Teams client, and if I was in something where actually I would have published the Google Calendar Assistant, it would appear in the top right as a tool, and it could integrate with the chat. So check out Microsoft Copilot Studio if you want to not deal with a lot of code and you want to have more just pre-built connectors to things. But other than that, it's probably not the place I would recommend starting for a dev. Let's fix that. Let's talk about where I would recommend starting and get in some code. By the way, there's a precursor to all of the next 5 things I'm going to show you, and that is you have a model that's yours or someone else's that you connect your code to. So all of the AI solutions that Microsoft kind of has for us rely on that. They've been in bed with OpenAI since the beginning, and there's tons of models that come out all the time, but you have to have at least one that you can connect code to be able to make all these solutions work. Azure AI does a great way of making all that happen and making it secure and responsible, so that's just your model deployment and your data. But if you don't have an Azure subscription, or maybe it's locked down and you can't provision whatever resources you want, here's a shortcut. I don't know if anyone has seen this yet, but it's kind of new. But at github.com/models, there is a sort of almost free way to have your own model deployment. So you can just select a model with the green action button on the left there, and you can go through the model catalog that GitHub has, and there's 3 at the bottom. You could deploy your own GPT 4.1 or DeepSync or Llama. And when you do that, it gives you an endpoint and an API key. And as long as you make a personal access token to that, all of your code samples, all of your solutions can work. So one of those 2 ways is like the first starting point. Either you're in an Azure tenant and you spin up through Azure AI Foundry a deployment of a model, or you use GitHub. Does that make sense? That's a precursor to all of the next things that we're going to look at. Cool. Okay. So the first one, AutoGen. Oops. AutoGen is a framework for creating multi-agent AI applications that can autonomously do things, right? And this one, I will be honest, this is the one I have used the least and is least interesting to me, because in listening to the people who run the product, it's really best for researching and prototyping. It's meant for experiments and proof of concepts, and it's really like the cutting edge. So think of AutoGen as like a sandbox and a playground. If you have a business scenario where you want to have 2 or 3 agents in a team kind of playing together, and you don't want to worry about writing code because you just need to prove an idea. You might throw the solution away over time, but it's a great first playground if you are in that space. And I'm really not. But if you are, it looks like this. AutoGen as a framework is at the bottom there. It has kind of a core set of libraries and frameworks, and then you extend it with extensions. And at the top, you can either bring your own app that kind of oversees all of it, or you can use the Magentic One orchestration AI, multi-AI app. And then there's two ways to like interact with it, either the studio or through a CLI, through what they call the bench. I think it's kind of really meant for someone who's really on a research team, to be honest. But if you use the studio, it does give you kind of a way to visualize your orchestration of AI agents. You can drag and drop them in certain ways, and you know, it's kind of nice. But as I said, this is not really, again, my preferred one, but it's a good one to start with. But I did promise some code. So there is a GitHub package, AutoGen for .NET, or AutoGen for .NET, that does allow you to write C# code and bring in familiarity. And this C# code starts after the using statements with, like, the first thing is, where's your model deployment we're going to use? And that's why I was talking about the precursors earlier. You give it the model, the endpoint, the API key, whatever, and then you register agents, and you can represent, you know, I'll use a proxy agent or use a team agent, however you want. This more to it, but I'm not going to do a full deep dive into this piece of code because I'm saving that for the next example. But again, it is doable from either a code point of view or from that studio. And that's AutoGen from an overview perspective. This one, this is my favorite one. This is the one for everyone in the room. If you only pay attention to like a couple minutes of this talk, pay attention for these next couple minutes. Semantic Kernel is built for us as developers. It's enterprise grade. It can handle delivering AI agents and other things at scale in the AI world. It's stable, it's secure, it's predictable, and it's really production ready. It's an SDK that Microsoft pushed out, I think at the beginning of last year even, for the very early parts of delivering AI solutions. And it's an orchestration SDK still, but the power is in all the things it does for you and all of the ways it allows you to customize what models you work with. In 2 lines of code, you could switch between a model deployed to OpenAI directly, or to Azure, or to a local Ollama running model. And all the other AI services that it connects to are kind of available in the SDK. You bring in one NuGet package, and you have it all. It also gives you a way to connect chat history to your assistant or your Copilot through, again, third-party services or things running locally. It allows you to have agents and orchestrate them, plugins, prompts, planners, filters for responsible AI, telemetry. It can kind of do everything. And it's the one that has the most use cases and delivers the most functionality, especially in C#. So to start to explain semantic kernel, it truly is a kernel in the middle. And when your app asks for something, it helps you with model selection. If we're going like, you know, top left to top right, how to handle system prompts and prompt templates and making sure that the communication of prompts is done correctly, invoking AI services through plugins and planners, marrying a response from an LLM with your custom function or custom plugin, and then delivering a result to your application. It does all of that stuff for you. And you can do it in a very small amount of code with very out-of-the-box things, or you can get very complicated and customize every level of this chart. It really is the brain. It orchestrates how to work within your C#, and it gives you control over just about everything. And one of the newer aspects of it is that this idea of agents and doing things. Remember my definition of agents, right? Understand context, work on a process, retrieve information, and do an action. Well, this is an illustration of how you can do an action as an agent in Semantic Kernel. So it starts kind of in the middle there with the prompt, and the prompt that the user is asking for, you can understand the intent that it wants to write a short poem. And there's this concept in Semantic Kernel of a planner. And the planner understands, because you've registered what plugins you have, so the top of the chart is all these plugins about brainstorm or email generation or writing a short poem or doing a full story or translating language. Each one of those things has metadata in your C# that the planner of Semantic Kernel can read and understand and help derive what's the right function call or plugin to match this intent of this prompt. So it goes to the planner, and in this scenario, because the person's asking for a short poem, it understands how to pick out short poem as a function, and then it returns by calling the function with the prompt and gives you that result. And it does that kind of automatically. And this is the thing that really kind of impressed me is, even if you have multiple plugins, you're not directly wiring anything up. The planner and the kernel does that work for you. Where before it might have been like a lot of if statements or parsing out intent. There was old ways to do that, but they were not great. Another way to think about it is that if you didn't have Semantic Kernel and you wanted to write C#, you'd have to do all these things. You'd have to understand how to parse JSON, provide history, do function calls, return results, repeat steps. There's just a ton of crap that you'd have to do if you didn't have Semantic Kernel. So hoping the theory part of it makes sense, let's see it in action. And I'm hoping that this video works. So this is me in Visual Studio. All I'm pulling in is the NuGet package for Semantic Kernel. And I'm using a console app with kind of the minimum required items. So I've got a couple using statements. I'm building a kernel through Create Builder as part of the Semantic Kernel libraries. I'm adding a chat completion service, registering a couple plugins, and then invoking a prompt, which is about, please let me know what time it is. And then I've set up a chat history where I can call that completion service with a history, a system message, and a prompt. And I asked it two questions. What time is it, so it could go through my custom function, and also something about the Thunderbolts movie that we're all going to watch later today, hopefully. People staying for the Thunderbolts movie? Okay, wow, only a couple of you. Hopefully you can make it. But that's, roughly, 30 lines of C# code to handle calling the prompt. And without that Semantic Kernel SDK, I think it would be hundreds of lines of code. It's crazy how much it shortcuts and how much it saves you. Now, as I said before, my day job is about building websites. So console apps are kind of cool. It's a nice way to prove a concept and maybe do a test or something. But I really wanted to put this into a web app. So what I have here next is I have a standard ASP.NET Core .NET 8 MVC site. And I'm using Semantic Kernel in that site to provide a chat agent to an existing application. So this is my program.cs of that website. And if I get this to run, there we go. I have some keys at the top, but right after our standard add controllers with views, I'm creating a kernel builder object. I'm putting in some plugins to maybe go after a home assistant scenario of lights and sensors. And I'm adding that kernel builder into a dependency for the rest of my app to use. So you can see it's a very standard MVC app. If I go to my chat controller, I'm accepting a post, and I'm using a chat history object, the prompt from the user interface. I'm setting up automatic prompt function call through the execution settings right there. I'm then calling out to my Azure AI service deployment model, and I'm going to be able to use that to my very fancy MVC site build an assistant that's completely in my control, ask it some questions about what can you do. So I'm just asking it the status of my lights, because again, we're kind of faking like a Home Assistant scenario. And it's telling me through my function call that I have a couple lights, some are on, some are off. Apparently my Christmas tree is still on. So I'm then telling it, hey, can you turn off the Christmas tree? And it's faking the result, of course, but then it's telling me that, yes, I was able to turn off the Christmas tree. So you can still ask it about other things, and it may not know all the answers, but there wasn't a whole lot of code I had to add to an existing MVC app to get the chat to work, right? In fact, for this specific example, I think it took me longer to get the UI, the JavaScript UI, to pop open and close without issues than it did to write the AI part of the solution. So that's pretty cool, right? Semantic kernels is great for that kind of stuff. Whether it's console, whether it's other types of projects, it kind of works. Past semantic kernel, there's a new kid on the block. This one is called the Microsoft Extensions.ai, or MEAI for short. And it's similar to semantic kernel because it is definitely a code level solution. But the definition is that it's a set of core libraries defined for collaboration in the .NET world, including semantic kernel. And its goal is to act as a kind of a unifying layer underneath the hood of everything. And I read that and I went, well, wait a minute. Why do I have something else that does what semantic kernel does? And I got some confusion. So I started to dig in a little bit. I did find this chart. And it looks similar to some of the other charts that we saw with semantic kernel, right? You have your application at the top. You have libraries in the middle that can handle calling LLMs and dealing with different models. There's support for iChat client and chat history. And it abstracts some of the low-level things of having to deal with the parts of AI in .NET. And I looked at that chart, and I went back to the beginning, and ultimately I came out like this. In fact, that's not accurate, more like this, gray hair. Had to add gray hair into the image. So hold on. We've got Copilot Studio, AutoGen, Semantic Kernel, and MEAI. What in the world are we doing here, Microsoft? Seriously, this is classic, like what's going on? But the good news is that the semantic kernel team and the MEAI team have gotten together, and they are trying to figure it out. They're trying to make the extensions AI as the low-level primitives that semantic kernel's built on, that AutoGen is built on, and other things. So think of it as like the primitive library that will hopefully be start to use in all these tools, and you may not know about it as much, or it may overtake the other two. I don't know about the future, but it's definitely confusing, and they're getting there. So you got to give them a little grace. Because when you look at it, the code samples are similar. In fact, we have our using statements. We talk about Microsoft Extensions.ai at the top as being used. It's got a couple other things like handle vectorization. But here in the middle is the main difference. This, what is this, like 7 or 8 lines of code, handles your credentialing, creating your option to talk to your model service, where to go to get it, and then this one is connecting to that GitHub's models that I showed a little bit earlier, building you a client, and also handling a few other things, which I'll talk about in a second. This is a lot less code than semantic kernel, right? Semantic kernel, it was like 20 or 30 lines, a lot more options, a lot more things you could do and customize. This is meant to make it kind of easy to just use without maybe being able to customize every single thing under the hood. And what I'm showing here is actually available at the .NET AI template. It's a .NET New template, and it's a Blazor app that makes an assistant. And not only am I a huge Detroit Lions fan, I also like to do CrossFit in the mornings to get some fitness in. And I have a buddy of mine who's learning how to be a certified level 3 trainer. And there's a set of PDFs that CrossFit gives you to study and create quizzes from before you take the certification test. So what I did is I made this assistant, this Blazor app, help him, or help both of us, learn more about CrossFit and study for it, using the .NET AI template. So if we get this video going, here you can see the template includes the using statements it needs to get all this working. We are calling out to our GitHub models credential. We're using modelsinference.ai to azure.com as a way to talk to it. We actually have something that's doing vector search based off the comments running locally. And then we have a data ingester that's going to open up any PDF that's running in my local data directory to ground my chat assistant with that knowledge. So I'm bringing my own file knowledge into a vector store, and I'm marrying that with the call out to the LLM. So I run this Blazor app, it pops up, the UI looks even a little bit better than my other one, and I can ask it questions, what plugins do you have, or what do you know, or what can you do? And it says, hey, I can perform and retrieve information, maybe give me a better question. So then I ask it specifically a question about CrossFit Level 3 certification, which is not public internet data. You have to have paid for this to sign up to get these things. I asked it for a quiz. It made a quiz out of those 50 PDFs that I have. And in fact, it gave me a citation of where in the PDF it gathered the information for to make the response to the prompt. All that was done with the Microsoft Extensions AI library. And all of it was pretty simple. I mean, that Blazor program CS file is small. And again, it's a little bit of a prototype, but the fact that it can do all that is super impressive. And I would encourage you all to check that out. So the .NET AI template, you can install it as a .NET tool or .NET new library, whatever it's called. Template, that's it, .NET new template. And you can get this spinning up in like 20 minutes. Okay, so that was MEAI. Gotta keep going. There's a couple more left. Azure AI Foundry. Now, most people in the room, I think, said that they were kind of starting to use this. And this is a really good new name for what was called Azure AI Studio last year. So Azure AI Studio has grown up. It's been renamed to Azure AI Foundry. And it's meant to develop, scale, and deliver AI applications for both business users and technical users. Although I would say it's definitely skewed more to technical users and developers. But it has a whole host of functionality around copilots, agents, model training, customization. It's secure, and it really is like the flagship of how Microsoft launches AI solutions to its customers. Looks a little bit like this. I would say there's even more total models available in Foundry than even at the GitHub solution. Not just Microsoft models either. All of, like everything you can imagine is there. But it has direct integrations into Visual Studio Code, Copilot Studio, and a Foundry SDK. So basically, you can use it everywhere. And it gives you a way to do tracing, debugging, observability, all that fun stuff. And it looks like this when you start it up. It takes over a browser session all the way. And on the left, you have a ton of different options for how to look at your model catalog, playgrounds, AI services, agents. This menu changes like every other week, I swear. The content understanding item there in the middle, that one appeared last week for me, out of nowhere. It's crazy how fast they're innovating this. So what happens in Azure AI Foundry is you need to make your own project and hub. And then all the other services connect to that. So here, I already have an existing project. It just shows that it's in my subscription, and I've given it a name, but you can make one and it asks you those three things. And then in your project, you can pick like which models you want to make available to use. So you can see there's like 1,900 models that you can choose from. It's every flavor of model you could imagine. And there's like even the new 5.4 ones just came out. You then kind of deploy your model the one you want. I think this is just a GPT one. And it gives you an endpoint, API keys. It's just like the standard thing you need to kind of get started. There's code samples in multiple languages, including C#. And if you want to choose different SDKs to pull down and use that, you can, different authentication types. And ultimately, it's a getting started guide. So same thing, yet another set of NuGet packages. These ones are just Azure.ai.openai or Azure.ai this, and code samples to do all that. So the first thing you're going to do, just to reiterate, you're going to make a project. In the project, you're going to make a hub. And there, you're going to start building things like agents. Once you have that, my favorite feature is you get a playground with no code or no time at all. You can customize in this playground and basically talk to that model as an assistant. You can change the way it's going to respond. You can see the token usage, which is key to understanding how many tokens you're using. Are you coming to limits? What's this going to cost you to run in production? The playground is super helpful. And I'm going to ask it, what do you know about this theater that we're all sitting in right now? And it's going to give me some information. And then depending on how I configure these variables, I can actually export that and use that in code in other places. I can actually change the system message or the main set of instructions for how to behave as an assistant. I can make it a little snarky and tell it to roast me instead of actually answer questions. And I can see it, kind of behave much differently. So I should be able to ask it one more question here, the same exact question actually, using the new system message, and it's going to give me a funny response, I believe. So here we go again, another attempt to milk me for information, blah, 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 blah. So you can really control this at a pretty fine level, okay? So that's your Copilot and your model. From there, you can make an agent. And the agent is where you can add in the ability to do some things. So you can give it an agent a name. You can add knowledge and training to it to ground the information that the agent knows about, so you can connect it to different places and features. And this demo will show that quickly, that I'm going to give it some instructions, some descriptions, and I didn't want to type all that in, but you can make it very specific to what you want to do, and then these agents are tied into your project and hub resource. So you can add knowledge, you can do actions, there's all sorts of stuff that you can do. And all the Microsoft ecosystem is kind of tied into it already, and they're working on adding more and more. But based off time, I'm actually going to keep going here. So once you set up that agent, you can then download it and use the code to do it, and you can actually see that what can you do or what I'm typing in, that thread of that conversation is where the code it gives you to start with happens. So Azure AI Foundry, super powerful, super useful. Inside of there is the Azure AI Agent Service. One more WTF moment of there's yet another tool to build AI agents with. And it's described as its own tool, but to be honest, it's part of Azure AI Foundry. So the Azure AI Agent Service is the new kid on the block. It just came out 2 or 3 weeks ago. It has the least information about it, but it connects to Azure AI Foundry, and it's more like a way to deploy your agents inside of your projects. You need to have the project, the resource all set up so it can use any of your internal Azure resources if you want. But really, you can do it through exporting the code in the Foundry, or you can make it by using just the pre-released .NET Azure AI Projects NuGet package. You do have to log in and authenticate who you are, and it will give you the code to do that. All these code samples, right? AutoGen, Semantic Kernel, MEAI, Azure AI Services, they're all very, very similar, but give you different capabilities to do so. So if you're like me, you've seen these 6 platforms and frameworks and libraries, and you're still confused. So I'm going to close with a little bit about how to use which one when, and when's the best case for them. This is a Microsoft slide, but their kind of pitch to enterprise is that AutoGen and Semantic Kernel are meant to orchestrate, develop your apps. You're going to deploy them into Azure AI Foundry and maybe Azure AI agents to manage them and make sure they work worldwide. This is the slide I tried to put together to make it all make sense. So from developing copilots and agents, you have low code with Copilot Studio, meant for business users, and then you go into Autogen, Semantic Kernel, and MEAI as full code solutions. A couple of them are really, really meant for developers who want to either build brand new AI applications and do everything, or sprinkle in AI solutions into existing applications. They have different target audiences. Some are more enterprise ready, some are more bleeding edge, and there's some good use cases for each. But here's a really great way to explain this. I would heavily recommend Semantic Kernel as the place to build, to gain knowledge. And then if you want to kind of add into existing, use MEA to do that. It's funny, ChatGPT told me to explain it like this. If you want to build a spaceship, use Semantic Kernel. It's modular, it can do everything. Warp drive, navigation, comms, it's all there, and you can customize each part of that. If you want to just build your own little warp drive and plug that into something to make it go really, really fast, then you use MEAA. So full-blown versus kind of incremental. Then when it comes to deployment and solutions of, are you going to use Azure AI Foundry or Azure AI Service to get all this out there? Really, I would say I can't really recommend the bleeding edge of Azure AI agent services yet by themselves. Focus more on Azure AI Foundry as a great way to handle low code and full code, a great way to handle technical things, full-blown solutions, and just incremental or partial solutions. It really is tried and true because it was called Azure AI Studio before, so it's been in use for a lot longer and a lot more people use it. So after those last two slides, I hope you're a little bit more at this point, like you think you maybe understand the differences as well as I do. And I thought I could close at this point. And then 2 days ago, Microsoft released this and just threw all the words together into some other brand new thing that I just heard about. So frankly, I give up at this point. I just can't handle it. No more new names, no more new things. A few other small tips. Prompty for storing prompt formats, whether system or user, that's where Microsoft is investing. I would look at that more if you haven't seen Prompty format. 5.4 is a small language model for building languages, agents locally. MCP, I would have loved to add more MCP into this talk, but it is seriously where everything is going and the hot new thing. It will work with Semantic Kernel as a part of a feature. They're working on deploying that like this week. Computer use agents, or what ChatGPT calls operators, are coming. Those are super cool, but not quite ready yet to talk about production. Definitely use those GitHub models for free. Check out the .NET AI template, and take a responsible approach. One other thing that, as you start using more and more of this, you want to make sure it's not hallucinating. You want to make sure it's accurate. I would check out Microsoft extensions, the AI evaluation. It's just one more NuGet package. And what that does is it gives you an automatic test framework to test multiple prompts, run it through 10, 20, 100 prompts at once, and make sure it gives you the expected results. What happens is you can use Test Explorer to see those results, and actually will give you an AI evaluation report inside of your pipeline, so you can tell as you modify your system messages, as you modify the way the application behaves, what's working, what isn't. A couple other things to just finish. There's a fantastic course by Microsoft to start out AI agents for beginners. This is pretty good. I do recommend that. I have a couple more links, and I'll post the slides in the Discord channel later to all the things I've shown. And of course, as of about, a couple of weeks ago, Satya is back talking about copilots. I just can't win with the naming. I seriously can't win. I do use Kensco to build all the things that I've shown you a little bit in some of the website stuff, so it's a great platform, but I'm out of time for right now. We'll leave a little bit of question time, but I hope you enjoyed it. I hope you learned a little bit about AI and how to build stuff for .NET developers. Cool. Any questions? Question right here. Sure. So first question, does MEA have state tracking? Yes, it has some ways to handle state. It's just another set of lines to add in that the SDK gives you. So that's the short answer for that one. How do I see it impacting content management UI? Hugely. In the content management industry, there's a lot of talk about how the user interfaces will not be built by static kind of representation of content. It'll be more a prompt, and the landing page of a website or resources center or search results are going to just generate based off LLMs reading the content in the CMS and delivering a page. And it would be a very different website appearance and use case for me versus you, depending on how I'm interacting with the assistant bar. So it's having a major impact. Right here.
Question around, I guess, RBAC and leveraging that with things like Semantic Kernel, the other options you have on there.
Yep.
I know that you can set up authentication to interact with the thing as a whole, but how have you implemented role-based solutions at action level? So hey, look, when this user is interacting with it, they can't trigger these actions. And how easy is that with
Sure. So the question is basically how can you use RBAC to kind of put governance in a solution and maybe actually make sure that one action can't be taken by another user? So they're not quite there yet with RBAC from the action capabilities. That part, you're still going to handle more in your system prompt. And you can put a pretty complex system prompt that says, if it's this kind of user, do this or don't do this. What I'm seeing a lot of people do is putting a security layer on top of getting to the assistant. And that way they're tracking who interacts with it, and based off who's logged in, finding out their role and their permission levels, and then changing the system prompt based off who's coming. So there's ways to handle it, but not quite just like a couple checkboxes. So not there yet, but that's a great point. Sorry, was there one more? I'm missing it. I can't see the lights right in my face. So if you've got a question, just ask it. Yes.
Whenever you were showing the code, for all your samples, you were showing your OpenAI experimented with on-prem AI servers integration.
Yeah. So the question is, in some of the samples I showed, do I ever experiment with using on-prem or kind of local model deployments versus the ones hosted in the cloud? Yeah, there's a great way that both MEA and Semantic Kernel handle that, and it basically can say, instead of add Azure OpenAI or add GitHub, it's like add local. And you can point it directly to an on-machine running model. And that's what 5.4 and 3 are kind of meant for. All right, everybody, I think I'm out of time. Thank you very much.